This paper, Michelangelo, Long Context Evaluations Beyond Haystacks via Latent Structure Queries, delves into the challenge of evaluating large language models' ability to reason and synthesize information from extremely long contexts. What are the limitations of existing long context evaluation methods?
Many existing benchmarks focus on retrieval tasks, where the model simply needs to locate specific pieces of information within the context. These tasks often involve needle in a haystack scenarios, where the relevant information is easily distinguishable from the surrounding text. However, this doesn't adequately assess a model's ability to synthesize information from multiple sources within a long context.
So how does Michelangelo address these limitations?
Michelangelo introduces a novel framework called Latent Structure Queries, LSQ. The core idea is to construct tasks that require the model to chisel away irrelevant information in the context, revealing a latent structure. This structure represents the underlying relationships and dependencies between different pieces of information.
Can you elaborate on how LSQ works in practice?
Imagine a long text describing a family's history. The latent structure could be a family tree, which is updated as the story unfolds. LSQ tasks involve querying this latent structure, requiring the model to synthesize information from different parts of the text to answer the query.
That's an interesting analogy. What are some specific examples of LSQ tasks presented in the paper?
The paper presents 3 tasks: latent list, multi-round coreference resolution, MRCR, and IDK. Latent list involves a sequence of Python list operations where the model needs to predict the final state of the list. MRCR tests the model's ability to understand ordering and identify specific pieces of writing within a long conversation. IDK assesses whether the model can determine when it lacks the information needed to answer a question.
It seems like these tasks are designed to measure different aspects of long context understanding. Can you elaborate on the specific capabilities each task targets?
Yes, each task focuses on a different aspect. Latent list measures the model's ability to track a latent data structure's properties over a sequence of code instructions. MRCR assesses the model's understanding of ordering in natural text, its ability to distinguish between similar drafts of writing, and its capacity to reproduce a specified piece of previous context. IDK evaluates the model's ability to understand when it doesn't know the answer based on the presented context.
How does Michelangelo ensure that these tasks are not simply retrieval tasks in disguise?
The key is the use of synthetically generated irrelevant information. This information is designed to be completely unrelated to the task, ensuring that the model cannot rely on shortcuts or memorized knowledge. The paper also emphasizes the importance of controlling the complexity of the tasks, which is measured by the number of relevant updates to the latent structure.
So the complexity of the task is independent of the context length?
Exactly. This allows researchers to isolate the effect of context length on model performance. The paper demonstrates that even with fixed complexity, models experience significant performance degradation as context length increases.
What are the key findings of the paper regarding model performance on these tasks?
The paper evaluates several state-of-the-art models, including Gemini, GPT, and Claude. The results show that while these models exhibit some long context capabilities, they still struggle with the more complex reasoning tasks presented in Michelangelo. For example, all models experience a sharp drop in performance before 32K tokens of context.
Are there any notable differences in performance between the different model families?
Yes, the paper observes that Gemini models generally outperform GPT and Claude models at longer context lengths. However, the rank orderings differ across the 3 tasks, highlighting the fact that Michelangelo measures diverse aspects of long context understanding.
The paper mentions that the MRCR task exhibits a particularly interesting phenomenon. Can you explain?
The paper observes that models from the same family, like Gemini, GPT, and Claude, tend to have parallel MRCR performance curves. This suggests that there may be shared training characteristics or biases within these families that influence their performance on this specific task.
This is intriguing. What are the implications of these findings for future research in long context evaluation?
The paper highlights the need for more sophisticated evaluations that go beyond simple retrieval tasks. It also suggests that future research should investigate the relationship between model training and performance on long context reasoning tasks. The paper's findings provide valuable insights into the current limitations of large language models and the challenges of evaluating their long context capabilities.
To wrap up, can you summarize the key contributions of this paper?
Michelangelo introduces a novel framework for evaluating long context reasoning and synthesis capabilities in large language models. It provides a set of minimal, synthetic, and unleaked tasks that are easily extendable to arbitrary context lengths and complexity levels. The paper demonstrates that current models still struggle with these tasks, highlighting the need for further research in this area.
Thank you for this insightful discussion on the technical aspects of